So today we're gonna start section 9.5, which is applications of trig. Our goal is to solve navigation and surveying problems. So we're still going to be using the same concepts that we covered in section 9.3 and 9.4 with law of sine and law of cosine. You're still going to be dealing with triangles, finding angle measures of triangles and side lengths of triangles. Now it's just going to be given to you in a context where you have to apply the information and use law of sine and cosine to find this information. You've worked with some of this before, but the main difference today is the way the angle measures are, the way the angles are actually measured, right? We're going to study bearings, compass bearings, and it's a little different than what you learned on how we measure from standard position on the unit circle. So let's get into that. So this is critical. The first thing we're going to talk about is, the course, right? So if we're given an angle measure, which is given to you as a course, mainly with navigation, it's different from the unit circle, right? So this example saying the course of a ship or a plane is the angle measure clockwise from the north direction. So typically when we're looking at the unit circle over here, we start here from standard position and measure counterclockwise for positive angles. When we're dealing with navigation, you can still kind of view it similar to the unit circle. I like to put a horizontal and vertical axis and a circle in here. But all measurements are going to be taken from the north direction. Okay, so that would be the positive direction of the y-axis on the unit circle. And all of these navigational measurements are going to be taken from the north measurement, and the positive direction now is clockwise, unlike the unit circle where it's counterclockwise. So that's something you have to kind of make sense of and lock in. So this first example, pretty basic. Draw the location of a ship on a course of 285 degrees. You'll notice that every time I deal with one of these problems, I draw myself, it looks like an X and Y axis, but really the way I'm looking at it is this is really like a north, south, east, west grid, where 0 degrees is starting at the north axis, and it rotates clockwise in the positive direction, right? So if we want to look at the course of a ship from 285 degrees, we're going to have to measure from the north line clockwise 285 degrees. Well, we know this is 90, this is 180, 270. So that would be 15 degrees above this west line, basically. And this would be a drawing of a 285 degree course, right? So everything here would be included on your page if you were answering a question like this, including the arrow here for the rotation. So estimate the course of this plane, right? So if we were using a north, south, east, west line here, this is my north line. The plane is traveling in this direction here. So, this is an estimation and an approximation. So again, I'm going to use the north-south line here, and I'm going to make an assumption right now that the angle below that 90-degree line right there is, let's just say it's 25 degrees, right? So if this angle here measures 25 degrees, then the entire angle from the north line to here would be the sum of 90 degrees plus 25 degrees, right? And that's going to be 115 degrees here, right? So this course would be 115 degrees. All right, next example. All right, so bearings. Bearings are critical. Bearings are measured the same way as we just measured, right? Everything's measured from the north line, and it's rotated clockwise in the positive direction, okay? So there's a couple different measurements when we deal with a compass, but a compass bearing here, it's measured the same way as we did on the previous two examples, but the difference here is whenever we're giving a compass bearing, we always use 3 digits, all right? So an example in this case is if we had a compass bearing of 60 degrees, it would need to be expressed as 060 degrees, right? So all compass bearings, regardless of what they are, must be used with 3 digits, okay? So what we want to do now is estimate the bearing of D from C. Okay, so it's critical that we read this correctly. So it's the bearing of D from point C. So that's measured from the north line where C is, and we're going to measure this angle here towards D. Okay, so again, I'm going to create my axis here to help me out. Now, again, this is an estimation, so I'm going to measure that the angle from the red horizontal at 90 degrees down to the direction that the bearing is. Let's just say that's 30 degrees right now. Oops. So let's just say that that's 30. And then I want to measure that bearing right there. So that would be 90 degrees plus my 30 degrees, giving me a bearing of 120 degrees. So that's the bearing of D from C. Now, the next question goes on and kind of reverses it. It says calculate the bearing of C from D based on our original estimate of this 30-degree angle here. Okay, so a couple things we have to look at. Again, since we're now measuring from 2 points in the reverse direction, I'm going to give myself 2 axes here. And the one thing that's extremely helpful in this case is that you can use the north-south lines of both of these axes here, or the east-west lines for both of these axes here. So right now I'm going to use the east-west lines here, and I'm going to view them as parallel lines because they are parallel. If you go back to geometry, if you remember, alternate interior angles from parallel lines are always congruent. So what we can look at here is that this 30-degree angle here is congruent to this 30-degree angle here from alternate interior angles. You could use the same idea from the north-south lines too, right? They both exist. Another key point too, I'm just going to make a note of it right now, is this, if you focus on this U shape right here, okay? So that's this north-south line, this transversal running this way, and then this north-south line right here. The 2 interior angles right here, and then this angle right here that I have sketched, they will always sum to 180 degrees. That's something you can use in the future. But for now, let's finish answering the question. So I want to calculate the bearing of D, I want to calculate the bearing of C from D right now, right? So if this angle here is 30 degrees, then I know that I can also use that 30-degree angle because they're alternate interior and mark that here as 30 degrees as well. And then what I want is I want the bearing measured from this north-south line all the way around back up to that, right? So let's kind of sketch that in for a second. That's going to run this way all the way to there. So that's going to be 90, 180, 270 plus my 30-degree angle there. So that's going to be 270 degrees plus 30 degrees, giving me a 300-degree bearing of C from point D there. Okay, so right now we really haven't been dealing with triangles. This is just getting you used to looking at bearings and measurements, and then we'll start getting into more application problems shortly. There's one more type of measurement we're going to look at. It's the surveying type problems where we talk about a compass reading. Okay, compass reading is a little different than a bearing, right? We're going to be using the terms north, south, east, and west often. But a compass reading, it's always given as an acute angle. That's critical that you pay attention to that, from the north-south line towards either east or towards west. So here, down here, this angle right here, we're given that this measurement from this green south line to the angle right here is 20 degrees. So what we can say is the compass reading for this direction is going to be starting at the south line, and it's 20 degrees east of the south line, okay? So we would express that as south 20 degrees east, which means we're starting at the south line, always starting at the north or south line, and then the direction, the measure of rotation, 20 degrees in the direction of rotation east. So for this example here, starting at the north line, we're rotating 45 degrees to the angle here, and that's in the direction of east. So this would be north 45 degrees east. And then for the last one, starting at the south line, 60 degrees towards the west. So that would be south 60 degrees west. So these are compass readings. And then we'll get into some application in a second here.